Hello guys, how are you? Welcome back. From our previous video, we were able to plot an extension versus force or load graph, right? And the graph was a straight line. And being a straight line, it shows that the force and the extension, they are directly proportional. They are directly proportional. When force is 0, extension is also 0. So the graph is from the origin. So the force and extension, they are directly proportional. And one other thing that we need to look at is the limit of proportionality. Having a rubber band or a steel spring, you cannot keep increasing the force indefinitely and hope when you remove that force, the spring will go back to its original length. That is not possible. There is a point which when you continue increasing the force, there will be a force which when exerted on that particular elastic material, when it is removed, the spring does not go back to its original length. Then in that case it becomes permanently deformed, and that point is this point here. This is the what? Limit of proportionality of proportionality. So you can increase the force, but if you exceed this point, this is the force, right? If this force, for argument's sake, let's say is maybe for a particular spring, it could be 5 Newton. If you increase beyond 5 Newton, the spring does what? It deforms. It's no longer, the extension is no longer directly proportional to the force or load. In that case, it doesn't go back to its original length when the force is removed. So it's permanently deformed. So that's what we needed to know. And also remember, the force, according to Hooke's law, force is directly proportional to extension. And from this we can have F is equal to Ke, where K is the force constant. Right? Force constant. So now let's go on and solve a few questions. So let's start with question 1. Examples. The diagram below shows identical springs without the load, and without the load, the spring has a length of 7 centimeters. When a load of 5 Newton is attached, it stretches to 9 centimeters. A. Determine the force needed to extend the spring by 4 centimeters. Okay, what we need to do here, we have to determine the relationship between force and extension. So from here, from 7 to 9, the change in length is 2 centimeters. The change in force, 9 minus 7 is 2, 5 minus 0 is 5. So this is 5 Newton. So what do we know? We know that Force is directly proportional to extension, right? So a force of 5 Newton will always extend the spring by 2 centimeters. So what's the question? The force needed to extend the spring by 4. So we need the force. We have the extension, which is 4. So we have x here. So what do? We cross multiply. But before, for this one, we might make it look easy by actually saying if we double the extension, the force also doubles, because from 2 to 4 is double, then from 5 double, that is 10, right? Another thing, from 2 to 4, if we multiply it by 2 to get 4. From 5 to x, we also have to multiply by same value, which is 2, and we'll get 10. But let's just cross multiply so that we see what is going on. 5 times 4 is equal to 2x, right? This is 20, this is 2x. What do? We divide by 2 both sides. Dividing by 2 both sides, what do we get? 22, 1. 22, 1 into 20, that is 10. Therefore, x is equal to 10, which means the force is equal to 10 Newton. Then Roman figure 2. What are we to find? What are we to find here? The force needed to stretch the spring to 17 centimeters. The spring to 17 centimeters. I don't want to clear this, and it's kind of messy, right? Let's just start afresh here. This is 2, right? This is what we have established here. We'll go by it as we solve this question, okay? We need to find, it's either given the force or the extension, but here we have a spring which is to stretch to 17 centimeters. We are to find force. Force is x. So what is the extension? It seems like we're not given, but we are given, because it's 17 centimeters. How? Okay, how the spring versus stretch we tell us 17 centimeters. So from where? That's the question. From 7. So the original length is equal to 7 centimeters. So the length here is 17 centimeters. E is equal to L minus L north, which is 17 minus 7, which is 10. E is equal to 10. So this is 10. Right? What do? We cross multiply. If we cross multiply, 5 times 10 is equal to 2x. What do? Divide by 2 both sides to liberate x. So I can just do this because this is 5th, okay? That's okay. 2 into 2, 1 into 10, 5. 5 times 5, that is 25. You can just use your calculator to make your life much simpler. So x, this x here is 25. We see that from 2 to 10 we multiplied by 5. From 5 to x we also have to multiply by 5. 2 times 5, 10, 5 times 5, 25. That's it. So the force here is 25 Newton. So B, what assumption did you make in answering A, Roman figure 2 above? Okay, the assumption here is the spring is not deformed, or rather the limit of proportionality is not exceeded, or force is still directly proportional to extension, or Hooke's law is obeyed. So still the same thing. So let me just write force is I made a mistake here. Just have to cancel this. Is proportional to extension, okay? Yeah, so this is the assumption. We can simply say Hooke's law is obeyed, or the limit of proportionality is not exceeded. Okay, that's question number 1. Let's go to question number 2. Well, here is number 2. The springs below are identical. Determine load M. Right, we are to determine this load. Remember, we have to work with this proportionality, right? That's the first thing that we need to establish. It's very, very important. It's crucial. So from 7 millimeter to 8 millimeter, the change 8 minus 7, that is 1 millimeter, right? Millimeter. So this is 1. And what causes an extension of 1 millimeter? What causes 1 millimeter is this force from 0 to 10. 10 minus 0 is 10 Newton. So 10 Newton. That's one thing that we have already determined, right? Now, to find M is the load. M is the what? Is the load. We need then to say to ourselves, what is the extension here? What is the extension from 7 all the way to 10? What is the extension? 10 minus 7 is 3. The load, what is the load? It's unknown to us. That's when now we cross multiply because they are directly proportional. So, but you can tell, I think these questions seems like are repeating, they're the same because I can quickly see that from here to here we multiplied by 3. From here to here we also multiply by 3. 10 times 3, that's 30. That means that is 30 Newton. But let's just cross multiply. 10 times 3 is equal to 1x. This is 30 is equal to x. You are done. So A is equal to 30 Newton. Right? B. Find the length of the spring when a load of 30 Newton is hung on the spring. Like I said, this will be a repeat thing. We cannot do this, guys. Let's change this. Let's change it to 40 Newton. Change it to 40 Newtons. And then it's kind of messy here. Let's start here. 10. It's 1. 3 was x. We can just continue from there. Here now we have, I'm just continuing from this one. So the length, find the length of the spring when the load of 40 Newton is hung on the spring. So this is 40 now. 40 is here. And then what do we have here? We have x. We have x, right? From 10 to 40, we multiplied by 10, 20, 30, 40 by 4. So we are going to do the same thing here. We are going to multiply by 4. You can cross multiply if you like. Still the same thing, but we are going to get 4 here. It's 4 centimeters. So E is equal to 4 centimeters. But the question asks us to find what? The length. The length. That is the new length, because the length with 4B is not the original length. The original length is 7 millimeters. This is the length without what? Than the load. So remember, L is equal to L naught plus E. So L naught, length without the load, no extension, just the original length, the natural length, that is 7 plus E. This is what we found, that is 4. So L will be 11 centimeters. So B is 11 centimeters. Right? See the assumption made. What is the assumption made? The assumption, once again, because we are saying 40 newtons, we are saying find the length of the spring when a load of 40 newtons is hung. It is not hung yet. We are just like imagining the length that will be as a result of this 40 Newton force when it extends. So we don't know, we are not sure. We are not sure. So we assume everything goes according to plan, everything is just favorable to us. Okay, so in that case we mean limit of proportionality is not exceeded. Limit of proportionality not exceeded. Or just say force is directly proportional to what? To extension. So that's the assumption, because we are not sure. Maybe the spring will deform if we put this load. It can just deform, right, and give us the wrong results. If it deforms, then the length won't be this value that we found, the value of 11 centimeters. Okay, here's another thing that I think we need to mention here. Okay, going back to this graph, guys, I've noticed some mistake with a lot of students. Sometimes, particularly in the multiple choice, if you find a graph can be drawn like this, then instead of force versus extension, it's extension versus force, right? Extension versus force. So we have this one, then, and this one, then. This is what? The limit of proportionality. This is the limit of proportionality. This is supposed to be a straight line. This is a straight line. Okay, then you are asked which graph is correctly drawn from this one. Which one is correctly drawn? Which one? So one thing that you need to notice here is this curve. This curve, it is towards the extension. Towards the X is for extension. So this one is towards the force. It's wrong. Suppose towards the extension. So the correct one is this one. So as the spring deforms, the extension becomes much larger than expected. So it bends towards the extension axis. So that's it, guys, with the questions on force directly, the force and extension, they have direct proportionality. Okay, thank you.